Welcome back, people of the internet. The comments on my previous video about the heat pump ratings and the headline figures and how confusing that can be and the lack of standardization, it really generated some thoughtful comments and some interesting things that I didn't know that I learnt from you guys, as always, nearly every single week. So I'm going to quickly run through some of those. Cavan O'Brien 6547, still learning about heat pumps, so sorry if I get things wrong. I did hear that there's a new refrigerated system that is coming in by January 2025. I think it's part of the incoming law or requirements within the industry. Heard about this the other day. Did I get it wrong, or should I cut down on the whiskey? I think, as far as I know, that may be the phasing out of R410A, which has a worse global warming potential than R32 or R290. So the ones I took as examples, 3 of the 4 were R290 units, which is just propane, has a very low GWP. So that won't be phased out anytime soon. But yeah, some of the old refrigerants are constantly being phased out as they look for more environmentally sustainable alternatives. Joe Wentworth 7856, another regular commenter on the channel, at around 11:10. I think you say output meaning input a couple of times. Still understandable, good video. So same journey we have been on. Yeah, brilliant. Sorry, that last video, it was a real rush and I'm good at tripping over my words as I waffle on. Thank you for pointing that out. I found the Mitsubishi information the best of the bunch for those who really want to go into the details. The EcoDan Air to Water data book has masses of information: min, part load, max power output of 5 degrees C increments of air and water temperature. However, yes, their 2-page data sheet is a bit weak. Yeah, that was the thing I was struggling with. Once you get some of these documents and you find the PDFs and you're able to locate them, then finding the data inside the PDF isn't that difficult. But getting hold of some of the past the 1 or 2 page data sheet, so difficult. A lot of things seem to be behind passworded like walls that they're trying to restrict the access of some of this documentation to approved installers only, which is frustrating to say the least. You always say I'm waffling, you keep waffling. We are learning plenty. Thank you. Great video. So genuinely can't thank you enough, as I'm about to pull the trigger on my heat pump. My biggest issue is 10mm microbore. Well, don't worry about the microbore, especially if it's copper microbore, then you probably have no reason to worry at all. As I said in a previous video, if you've got a heat loss of that particular room or that particular radiator, you might have 2 radiators in the room of less than 1 kilowatt, 1,000 watts on one rad, then you're definitely going to be safe on microbore, and I'm sure your installer will do the necessary calculations to get the correct flow rate and get the right amount of energy to the right radiator. Simply brilliant. Not going to waffle. One for the heat geeks to note: simple, clear and informative, totally in line today. Thank you for the positive feedback. Brilliant as always. I'm bang in the middle of my heat pump journey and all of this information is so useful. Thanks for sharing all your research, which must have taken you ages. Yeah, there's a lot of things that I've picked up along the way, and as I speak to people face to face in the kind of real world, I realise I've picked up a lot of knowledge along the way, and some of it kind of subconsciously as I've been studying and being able to converse with quite a few installers and people who are way more knowledgeable than me, trying to soak up some of that wisdom from those smart people. And I don't mind sharing it as long as people realise that I'm not qualified to speak on any of these issues, but I like to just put some information out there and just give people a pause for thought, and then they can do their own research. And if it just spurs people on to do a little bit more research and make some good decisions, then that's great. We're meeting the aim of the channel. KLMJ172, thanks for the info. The main thing that puts me off is noise levels, particularly overnight. I think the noise issue is massively overstated. This user, if your indoor fridge freezer keeps you awake at night, then perhaps an outside air source heat pump is not for you. Yeah, I've had people come and they've asked us if noise is an issue when they've been in our house, and you can't hear it. You can't hear our heat pump at all at any time in the house. well, I invite people to go out to the garden and go and put their ear right against the heat pump, and I'm happy to put it on full hot water mode to try and blast it. But for me, I mean, we've got the Vaillant Arotherm Plus. It is silent. There's just no noise issue at all. Where can I find the 4:1 modulation data for Vaillant air source heat pumps you mentioned in the video? Have I wrongly assumed that Vaillant low modulation was simply a ratio of the minimum and maximum litre per hour flow rates, which is closer to 2:1? Looking at their tables, it seems to suggest that there's no modulation whatsoever. Output goes up at higher temperatures with the same quoted COP. If output dropped and COP remained the same as temperature increased, then this would indicate modulation. So Vaillant control their heat pumps slightly differently to some of the other manufacturers. If you're asking about the modulation and the flow rate in litres per hour, then you're probably aware of the DT, the difference in temperature between the flow and the return. And some other heat pumps fix that DT, and they are targeting 5 degrees at all times, at all costs, and then they will adjust the flow rate of the circulation pump in the heat pump, as well as adjust the compressor, which can then adjust the heat output in 2 different ways, by the flow rate and by the compressor output. And I'm sure there'll be some engineers that will chime in on what I'm saying right now, as different heat pumps control in different ways. The Vaillant seems a little bit unique, that it doesn't modulate its flow rate. I don't know why it has a minimum maximum litre per hour flow rate, because I've only ever seen it at its maximum. And if you look on Heat Pump Monitor, delve into some of the real-time, real-world data of some of the people there's varying systems, and if you hone in on the Vaillant Arotherm Plus, they're always pretty much at the maximum flow rate. And the only time you see a little blip is if it's going in or out of its cycle, or if it's going in and out of domestic hot water mode into the heating circuit mode. How the Vaillant controls it is it does modulate the compressor, and so that's really where most of that 4:1 ratio is coming from. It can turn the compressor down to basically 25% of its maximum output, but it also Vaillant, cleverly or not, depending on how you look at it, it could, I guess, in some ways be an installer's nightmare, but they vary the DT quite a lot, and sometimes the DT narrows right up to like 3 degrees. I've definitely seen 3 degrees, and other times it will widen right out, and sometimes approaching almost 10 degrees DT, which doesn't seem to go along with a lot of the perceived wisdom and the established thought of heat pumps DT5. You don't want a big difference between the flow and the return, because the heat pump can't make up the difference, essentially. I don't know, it's something for you to delve into if you want to, but the 4:1 modulation data for Vaillant is you can find that if you look in the actual, I can't remember if it's the installation manual or the owner's manual. If you can't find those PDFs online, then send me an email to the channel email address, which you might not find if you're on a mobile device. You might have to be on a proper PC to find it. But the email address is upsidedownfork@outlook.com. I've got all of the Vaillant PDF stuff. I downloaded as much as I possibly could before they put it behind, like, not the paywall but the installer wall, so installers can still easily gain access, but us as homeowners, it's more difficult to get hold of like the schematics and the technical documents and stuff. But in those documents, it goes through more of the minimum and maximum inputs and outputs and those ratios, and so it doesn't actually state a modulation ratio of 4:1, but that's basically how I calculated it. On top of that, if you have a look at heatpumpmonitor.org, you will be able to see, if you pick out one installation, and if you just track that back over cold spells and milder spells, you'll be able to see that modulation of 4:1. Anyway, there's a lot of time. I hope you appreciate that answer. Completely agree. Minimum electrical input is so important to reduce cycling. A heat pump that is rated to deliver 6 kilowatt at -3 will struggle to deliver just 1 to 2 kilowatt of heat input when the weather is milder, spring and autumn. In your example, your minimum electrical input is say 600 watts, but in the milder weather, 10 to 15 degrees, you'll be getting a cop of around 5 to 6, so it's chucking in 3 to 3.6 of heat still. If they could modulate down to just a couple of 100 watts, it would save electricity consumption and reduce cycling by trickling in just a kilowatt or 2 of heat when that's all that is needed. So yeah, I see what you're saying, but COP is not the same as the modulation ratio. Maybe I'm misunderstanding this, but if we're saying that the potential maximum output of my Vaillant Arotherm Plus 7 kilowatt, if we're saying the maximum is 10 kilowatts of output, and we're saying the modulation is 4:1, then we're roughly saying that we're going to be inputting more like 2.5 kilowatts. But yeah, it's going to be inputting more than we would potentially like, and then it turns into more of a conventional gas boiler heating system, because it's not running so steady state. It's more, on for 10 minutes and then off for a while. But yeah, it's not the best, but at the same time we're still kind of having parity with the very best gas boilers, that most of them also just modulate down to about 2 kilowatts. So finding any heat source that goes below that, then you're really looking at passive house, and you're looking at MVHR and things like that if you want to get below the couple of kilowatts. The thing is, it really shouldn't be difficult to calculate. They're already working out heat loss at -2 delta 23, so it can't be hard to then also get a figure of a couple of degrees above the average temperature for your location. That way you have the effective working range, so also know what the real world minimum heat output requirement is. Given that they already know the output figures at various temperatures and flow temperatures, surely it then becomes easier to find the right size that will minimize cycling. In my mind, in a 3D graph, you've got a cone that represents operating capabilities and a line that represents your own heat loss requirements for individual property. The correct heat pump would see your line stay entirely within the operating range, both at high and low external temperatures. Interesting. Okay. Do not agree. Minimum electrical input is not so important to reduce cycling. To reduce cycling, minimum heat pumped into the building is so important to reduce cycling. I might be missing something here, but how do you control the heat output without controlling the electrical input while maintaining COP? Yeah, it's a good discussion to have, and I'm glad that we can all engage on that. What is the most important thing? Is it reducing cycling? Is it your COP? Or is it the actual running cost? I think the thing that it ultimately comes back to is when it gets mild, the running costs are so incredibly low, because you're putting very little heat into the building, which ultimately, that necessitates a very small amount of electrical input. So the cost is very low. The COP naturally is pretty good, even if it's cycling, because the temperature is so much warmer outside. So it doesn't become as important. I think for me, basically, it seems like below 7 degrees, but my heat pump seems to sit in the sweet spot, kind of at 4 to 7 degrees outside. Above that, it's kind of cycling a bit more than I would like, although it's fine, it's not short cycling, but I would like my heat pump to probably be a bit smaller and reduce that cycling a little bit. And then below 4 degrees is when it gets colder, and so the COP starts dropping. And so I like the operating range of 4 to 7 degrees, but also above that, it's no big deal. And maybe, my buffer tank, that might help a little bit, and I've got reasonable system volume here, so it's minimizing the short cycling somewhat, and I know that the algorithms inside the Arotherm Plus mitigate short cycling to some extent. Right, anyway, move on. Good points. Thank you for all three of you for chiming in on that one. Nice overview. The heat loss of our house was estimated at 6.1. I was a bit surprised when the installer recommended a 5 kilowatt Vaillant heat pump. He was right, and the heat pump copes even when the outside temperature dropped to -7 degrees. It also has no problem heating a 300 litre hot water tank to 52C. Yeah, the only advantage you would have had going a 7 kilowatt heat pump is it would have heated the tank much quicker, much quicker. I'm actually surprised that the domestic hot water performance jump from the 5 kilowatt unit up to the 7 kilowatt is considerable, especially at lower temperatures. But the 5 kilowatt will do it fine, and for the rest of the time, the 75% of your energy use is actually in the heating circuit, not in the domestic hot water, and yours is going to be way more efficient than mine. So good for you. Can I ask who your installer was, and did they fit a buffer tank or a low loss header to your system to balance the lower flow rates of a 5 kilowatt Vaillant? I used a company called Veto Energy. So I believe Veto Energy were originally, that's what HeatGeek stemmed from, isn't it? I believe that's the actual original company before the rebranding of HeatGeek. They're not cheap, and looking back, I think I paid more than I need have. No buffers were needed. I have 15mm pipes or rads. We have a total of 14 rads. 3 bed, 14 rads and 3 bed is quite a few rads. So they were all over 30. Some of the rads were designer. Total was 21k from use, which you can subtract that. Okay. So excellent. Yeah, potentially the 3.5 kilowatt, probably you would have scraped away with it, but 5 kilowatt is probably right in the sweet spot of comfortably covering your heat loss even when it gets really cold and having reasonable hot water performance. So yeah, really good. What else was I going to say on this? Yeah, anyway, I'm glad you trusted a good installer. This was the right video at the right time for me. Thanks. I'm getting quotes at the moment and have been struggling to understand why the heat pump recommended have varied so much from 7 kilowatt to 12. The 12 kilowatt Samsung pump that one company has recommended seems higher to me given our heat loss of 6.5. Wow, but the company has generally been very good and thorough, so I'm inclined to trust. My concern is less that they've got it wrong and more that they're just being overcautious. In reality, we only heat the house to 19, so I'm concerned about a pump that's pretty oversized and ends up cycling a lot. Plus, it's a chunky beast. Anyway, I'm waffling. Thank you. That is my tagline, unfortunately. I would have a robust conversation with your installer. If your heat loss is 6.5 kilowatt, ask them for their calculations, ask them for their sums. If they are a good company or a good installer, they'll be able to easily provide that with you and they won't be upset at you asking. If they do get the hump at you, trying to mark their homework, as it were, then maybe you do need to start looking elsewhere. That does seem very excessive. And considering the experience that I'm having with cycling, I would say that any more than what I've currently got would potentially be causing issues, and I'm just on the edge of acceptable cycling, especially when I compare to some other people. There's quite a few Vaillant Arotherm plus 7 kilowatt heat pumps on Heat Pump Monitor, and especially when I look through some of their data on the same day, there's some that geographically aren't far away from me, similar ambient temperature, and I look enviously at some of them where their units are more closely matched to their heat loss, and they're doing better. Their COPs they're not a million miles away because the Vaillant somehow has great control and it seems to work well even when the installations aren't perfect, which some other manufacturers seem to struggle with. But anyway, all that waffling aside, have a good conversation with your installer. This has been so helpful for my particular situation. I've just bought a 3-bed detached 112 square metre and want to get an installation from Octopus, which currently uses the Vaillant Arotherm. I'm going to do a loft conversion and possibly a single story kitchen extension. So add in 70 square meters from your video. I'm taking the assumption that installing a 7 kilowatt now will be able to handle the addition of, say, 4 room radiators and a bathroom one in the future. So I could install now to take advantage of the £7.5 rebate, and no, it should be able to support future expansion. Andy, a few points there. I don't believe Octopus use Vaillant. They were just using Daikin. Oh, yeah, Fred Gray, here we go. I didn't know Octopus use Vaillant now. I think they used to use Daikin, unless they've changed something. But as far as I understood, they were only using Daikin, and then they were going to move on to their own Cozy 6 or whatever those heat pumps were, which ultimately came about because they acquired a company called Red in Ireland or Northern Ireland. Decent heat pumps, and Octopus acquired them to bring the technology in and to try and make a shrunk down nice version that they could roll out quite quickly without getting Daikin involved. In terms of installing for future things, it can always be a risky one, and assumptions don't work very well with heat pumps, and rule of thumb don't work very well with heat pumps. You need to have a room by room heat loss calculation, both for your current house and for your plans going forward, and you can easily do that. Even if you don't have comprehensive plans now, most competent surveyors will be able to put together a heat loss of what your future building will be, and you'll be able to split that in 2 halves, and then your installer will have many options at their disposal of how they mitigate cycling in the short term. It's obviously not ideal, but like you say, you can jump now. You'll save masses of carbon emissions straight away. You'll benefit from 0 rated VAT and the £7.5 rebate. And then as long as you've got decent heating circuit pipework, then you could easily connect in to the next part of the home. And potentially, if you are building a single story kitchen extension, you wouldn't really want to worry about radiators. You want to go straight for underfloor heating. In that case, the additional cost is not that much when you're adding a single story kitchen extension. And if it's a kitchen extension, it's a lovely thing to put under a tiled floor. Michael Winkley, so much cycling, definitely got an oversized heat pump. Yes, I have. Totally not relevant to heat pumps, but you might be surprised that the electrical consumption of a microwave is typically about double what the rated cooking output is, and they run at 100% duty cycle. Interesting. So where is the rest of that energy going then, if that's not being... Is it losses at the transformer that come out of the vents as, actual like radiated heat rather than nuking? Okay, I don't know enough about microwaves, so I shouldn't speculate, but that is interesting. Yeah. We are in the process of getting a heat pump from Octopus. Our heat loss in the house is 6.5. Octopus initially spec'd the 9 kilowatt Daikin. However, the 9 kilowatt has a minimal electrical input of 950, whereas 8 kilowatt heat pumps minimal electrical input is 325, a massive difference that ultimately would have cost me all my bills. Discussed with Octopus, and they were happy to change the heat pump to the 8 kilowatt. Apparently the 4, 6 and 8 kilowatt heat pump are all exactly the same. The first two are limited by software only, so it makes sense that they all take the same amount of electricity to run them at the lower output end. Again, the 9, 11, 13 and 16 kilowatt units are all the same unit, thus the reason why there is such a difference in minimum electrical input between 8 and 9 kilowatt units. This is something I didn't address in my last video, but Daikin aren't the only guilty party here. If you do dig in, and there's a great thread on the Open Energy Monitoring Forum discussing some of these issues. This is an example of Daikin. They really, in physical terms, from what I'm seeing here, I thought they'd built 3 heat pumps to cover these sizes. And as you can see, there's 7 different sizes, but I thought there were 3 heat pumps for the 7 different rated outputs. You're telling me there's 2 physical units that cover 7 outputs, and then they're just software limited. Now, that's not unique to just heat pump manufacturers. I work in the motor trade. That is also a thing that Mercedes-Benz have been doing for years. They badge the C200, the C220, C250 diesel, and sometimes there are some mechanical differences, but most of the time it's just the mapping on the engine software that changes the output and the amount of turbo boost you get, and they put another big label on and they charge an extra £1,000-2,000. But that is kind of one of the problems we're going to get with sizing heat pumps correctly if manufacturers are doing this more and more. Hopefully they're not. Hopefully they're going to be going the other way. But as I mentioned, for Vaillant, I believe I'm going to get this wrong now, but the twin fan units, I think that's a 10 and a 12. I think hardware-wise, those are the same, and the 3.5 and the 5 Vaillants are also physically the same. I think the one that I've got, the 7 kilowatt, may be a unique standalone model that doesn't have any carryover. But yeah, you're obviously you might as well just sell an 8 and a 16 and just forget those in between sizes, because I guess the only reason they badge them lower is they may lose some market share and they may lose some sales, because people will look at those headline figures and go, well, why are you giving me an 8 kilowatt heat pump when my heat loss is 4? So they just change the badge and software limit it, which isn't great. It's not good for anyone. But yeah, good for you that you opted for an 8 instead of a 9. Oh, I missed this, sorry. I have the 11 kilowatt and it can run much lower than 950 watt. The other day I could see on our smart meter the whole house consumption was showing 844 watt. The compressor was running. So to see how much it was using, I turned the pump off. The house consumption dropped to 84 watt. That means the air source heat pump was using 760. Still not as low as 325, but at most on mild days it will only cycle about 7 times in a day, and our SCOP is 4.3. Yeah, that's the point I was making earlier. It is less of an issue as it gets mild, and as the appliances start cycling more because it's mild. The COPs are great anyway because ambient temperature is good and you're not putting much heat in, so the cost is massively reduced. And so it's frustrating because ultimately, sure, if it's the difference between 844 and 325 watts and not having so many starts on the compressor as well, wear and tear and all that stuff, it would be better. But yeah, anyway, that's one of the reasons I made the video. Interesting video. I'm assuming that as that energy demand drops, you will be along the heat curve and therefore the flow temp will be lower. That again increases COP, doesn't help the low modulation. I did have the chance to get a 5 kilowatt Arotherm, but went for the 7 kilowatt as my heat loss is 7.6 at -3. Oh, by the way, second-hand pumps can be had. I have my 7 kilowatt as it's DIY and putting in 35mm primary and twin mag and Y strainers because twin mag and Y strainers because I can. Yeah, I'm sure you commented about this before. The thing about well, on a 7 kilowatt unit, you don't need any more than 28mm primaries, and I've got both a magnetic and a Y strainer on mine. I don't know if you mean twin, that you're putting it on the feed and return, or just that you're putting both on it. But 35mm primary seems excessive, but your heat loss is higher than mine. So yeah, who knows? Good luck on your DIY project and keep us updated on how that's going with your time frame and stuff. Are you just waiting for the weather to kind of get past the heating season before you cut off your gas boiler and go for it? Okay, this is a long one. This is a great comment. Colin Good 3702. You must work in the industry somewhere. I suggest everyone go and read this or pause the screen and read it because it's a long one. So I'm not going to read the whole thing out to you. But a couple of points. You're comparing to the car industry that I work in the automotive sector, because it's a very mature market and it's a heavily regulated market. They all perform exactly the same test procedures under lab conditions. And although we saw things like Dieselgate, for example, which is a little bit of a cheat, at least the ratings that you read are all conducted through exactly the same procedure. It's not. It is comparable in some ways, so I understand what you're saying, but it's not like, Mercedes aren't going to say, well, our vehicle is 500 horsepower, but we've tested it at sea level altitude and we've tested it at minus 10 degrees when the air is really dense, and so we can produce more power. And then you get Ford come along and they say, well, our vehicle produces 200 horsepower, but we tested it at 2,000 feet of altitude when it was 30 degrees, and so it was thin warm air and up at altitude, and all of those factors. That for me is the comparison of what's happening with heat pumps. You talk about the independent testing that needs to be done. So every heat pump that's sold in the UK, as far as I understand, has to go through the test, and you can find those figures on the MCS website. But everything that's published there is just maximum outputs. It's just like flat out output as far as I can see, and it's very simplistically truncated to show at 45 degree flow it will produce 4.5 cop, and that's kind of it, which doesn't really help you at all. And the annoying thing about that is the physics seem to show us that all of the heat pumps perform almost exactly the same. That MCS database of heat pumps is so frustrating. It's such a waste of time. It's so worthless, because you could look up 20 heat pumps, and I have got a spreadsheet somewhere when I was considering some of the options, and the difference between them in the COP is absolutely nothing. In the real world, they're potentially could be nothing as well, but I think from what I'm starting to understand and from studying heatpumpmonitor.org, the control strategy seems to be quite key, along with, of course, the installation and these other variables that you talk about, and obviously the end user and the homeowner and how they actually try and run their system. But yeah, a lot of good points in there. Thank you so much for sharing that and raising that. I grew up and lived most of my life in cold houses. It's fine to have the house get a little cooler when it's below -3 outside. So my strategy is to put a jumper on, cook a meal, and buy a smaller air source heat pump. I support your decision, the Bad Octopus, and I would be very happy with that as well. I know there's many people who watch my channel who will be trying to lynch you right now, but I fully support that ethos. Enzo, I faced with the same difficulties when I looked at pumps suitable for my house. I do confirm that it is very hard to find useful info when you want to know more than the basic info. In Italy, the law is to inform about power output and COP at 7 degrees outdoor temperature and 35 degree flow, and also at 45 degree flow. Typically, you must be an installation company to have access at more data. This is what I was saying. Yeah, so similar you're finding in your nation as well. In Italy, more data are available to everybody from LG for their R32 Therma V monoblock S versions, even if I feel that some info is possibly not accurate. I compared the 3 units that are rated 12, 14 and 16, which are certainly the same machine assembly with just a different tuning. Here we go again. One version of hardware with software limitations, or just rebadging, just straight rebadging. On paper, they're rated for modulation down to 11 to 13% and the circulating pump down to 10%, but I could not find much info on what the COP will be at those low power output. There is, however, a table suggesting data for a typical system at various external temperatures. Interestingly, as the power output is reduced, the COP gets better. Among the 3 units of the same construction, the lower power are slightly more efficient. Interestingly, on the user manual of the same units, you have many different control options. You can select the delta T or even the circulation pump speed, if I correctly remember, which should allow you force the heat pump to operate at different power outputs at a given temperature. But this is my theoretical understanding. Well, that makes sense what you're saying, and interestingly, the LG thermo units don't have a good reputation in the UK. I mean, it's been slaughtered now since that Heat Geek video came out, but certainly one of the units that was the most complained about on the
Heat Pump UK Facebook group was regularly the LG unit. People were just frustrated with the controls. There's no way to calculate your COP. Installers were frustrated by part replacements. A lot of criticism on that group about the LGs. Can I ask where you get the usage info around 12 into this? We also have Vaillant Arotherm. Email me. I'll send you whatever you want. I'll send you all of the data sheets. And maybe I should set up like a shared Google Drive or something that you could have access to, because I've got a lot of PDFs related to the Vaillant Arotherm Plus. The Vaillant Max power input numbers do seem to be available on the installation and maintenance instructions PDF on page 46. Not sure what the external design temp is, probably -2 or 3 is my guess. I contacted my DNO recently and even they thought 7 kilowatt was peak electrical power input, so it's not just consumers. Exactly that. My DNO, exactly the same. They presume the same thing. 7 kilowatt on the badge, it must be 7 kilowatt input, and it's one of the reasons why we have such stringent DNO process to get a heat pump connected, which I don't know if they ever will do away with, but ultimately, like putting a kettle on is more of an issue for the grid than it is having loads of heat pumps. I'm in the US, so my system is very different. Air source heat pump, air handler and air ducts throughout the house. I've seen the heat pump come close to its rated maximum input power, but at 10 C below the design temp, -18 here. Those days were big outliers on my data. Other people in my area with similar installs added supplementary heat and or turned down the thermostat for those days. Our house is about the same size, but the temperature swings here so much. My heat pump is 14 kilowatt and probably only a little oversized. Interesting. Thanks, David Stewart, for sending us a message from Colorado. It's interesting to see what different parts of the world are doing. As far as I understand, the US is well ahead of us on air source heat pumps. To be fair, the calculations and the MCS requirements are complex. If I was an electrician or a plumber, I'd just prefer to use a bunch of rules of thumb and avoid the paperwork. Yeah, don't blame them at all. I'm pretty sure that a 5 kilowatt heat pump will be fine for my house based on detailed calculations and closely monitoring my current gas system, but I suspect that I'll be quoted 7 kilowatt and above when the plumbers come around this week. There's no incentive for a plumber to quote a smaller system, less money overall, and a greater chance of a customer callback when they're too cold. Rules of thumb are rules of dumb. It is essential to fully understand the specification in detail. There are no shortcuts. Yeah, I can understand why they do it. The only question there is the less money overall is not really a factor. The difference in cost between a 5 kilowatt Vaillant and a 7 kilowatt Vaillant is negligible. There's not really much in it. The only thing that a lot of less confident people will be adamant about is a buffer tank, and that does add cost, but that adds confidence and reliability. If you don't know what you're doing with flow rates and you don't know what you're doing exactly with sizing, then a buffer can deal with a lot of that. So good luck anyway. Not sure if you can help. I'm having 2 pumps and installers quote for 2 Mitsubishi EcoDowns labelled 11 kilowatts. From what I'm reading, Vaillants would be preferable all around. Agree or disagree? When you say 2, you probably mean a cascade system, two connected in parallel. Ben is in Sweden. Have your proper heat loss survey, as 2 times 11 kilowatts seems pretty extreme. Thanks, I have. They were teetering on the verge of what 2 9 kilowatt types do. However, given the refurbishment nature, whereby there is such a mix of new and old, and the incomplete nature of the build, we are trying to insulate further any old walls left, putting as much as possible into new roof plus insulated reflective felt and triple glaze. It's probably a nightmare to calculate accurately. The rooms are sizable and there is a 3-floor entrance atrium to make matters worse. Sounds grand, but it's not. It's just my idiotic design. I didn't pay for a whizzy architect. Okay, you clearly have quite an extensive house to either need 18 kilowatt or 22 kilowatt somewhere. in that kind of 20 kilowatt region. That is pretty massive. So I'd definitely get another quote or two, or at least pay for another independent heat loss calculation. Yeah, it might be more time consuming, it might be complex, but it's not necessarily a nightmare. It's just more complicated if not all of the walls are the same and if there's varying levels of insulation. But it's worth doing properly and getting it right, especially if you've got a big system like that, a big cascade system. The good thing, I don't know how. So your original question was Mitsubishi versus Vaillant. If you look on heatpumpmonitor.org, you'll see that Mitsubishi's perform very well, Vaillant's perform very well. They do have their pros and cons, which you could probably read up on, and maybe you're seeing a lot of enthusiasm for Vaillant's at the moment, because they do perform very well, and a lot of the installers seem to like the simplistic nature of the wiring, the commissioning, and they just seem to work quite reliably. But if someone knows what they're doing with Mitsubishi, then they seem to get really good performance from them as well. So I'm not sure if Mitsubishi can work in cascade in the same way that Vaillant can, but Vaillant's can basically fire up. So in the milder months, you'll only be running one of the two pumps, and you can have one running the heating of your home whilst the other one does the domestic hot water, for example. And then as it gets very cold and you might get close to your design temperature, then it will start kicking into the second heat pump to then bring on the full output of the cascade system. I'm not sure. I presume that Mitsubishi would do that. Mitsubishi are very experienced with heat pumps, more on the air-to-air side, but they've been doing air-to-water for a very long time as well. So I'm sure neither of those will be a bad choice. It's just getting the right installer and getting the right design is going to be way more important than choosing the manufacturer between Vaillant and Mitsubishi. Thanks also for this explanation, as I was thinking exactly. The rating was the consumption max, which would be very scary if you were potentially pulling 22 kilowatts of electricity. That would bankrupt anyone, even if you are having some sort of refurbishment and extension and obviously plowing a lot of money in. It would still be very very scary to think of the running costs of 22 kilowatts of heating. Manufacturers need to do a lot better with modulation. Problem is we need more awareness. I'll probably keep my 10-to-1 boiler until they do better. Okay, your 10-to-1 boiler probably doesn't modulate down to the minimum of what quite a few heat pumps can. If you look at the minimum heat output of your boiler and then compare that to a 5 kilowatt Arotherm Plus, for example, I'd be surprised if your boiler can beat it. And maybe a Wiesmann 200, I think maybe one of the Intergas ones goes down to like a 1.9 kilowatt heat output. But this shouldn't be a reason anyway. The biggest reason for jumping to a heat pump is the carbon saving. There will be some financial savings as well. Maybe the 3.5 kilowatt pump would have been the most efficient. It would be undersized at 70%, as some dedicated software recommends. Nothing is lost, and I recommend trying to find the temperature at which the pump stops cycling and heating to different temperatures during the day. It is now oversized only for 24 use, but not for 12, 24 or even less hours of operation. Yeah, that's correct. I have been considering bumping up the target temperature, especially as it's mostly running off the solar panel system now as well. But yeah, it's an interesting point to consider. Thanks for publishing your heat pump electrical consumption stats. This is particularly useful for me in calculating my battery size to cover not only my normal house load, but also the load for my future heat pump installation. Glad it was helpful. You're welcome. Thank you. Those are my suggested ones. Thank you, YouTube algorithm. I agree with all your suggestions. Heat pump monitor should be able to find minimum running input power for most units now. The better performing examples are often sat at that limit 24/7. Yeah, so the first part, correct. That's where a lot of my thinking and my understanding has come from, studying that and talking to some of the good installers who've corrected me on a few things. Some of them watch my videos and then send me private emails and say, yeah, well, we watched this, maybe tweak that a little bit, or the way you expressed that maybe wasn't quite right. On the second part, the better performing examples are often sat at that limit 24/7. Not in this milder weather. All of them are cycling, even the very best ones. Even those who have got full underfloor heating, masses of thermal mass, they're still cycling. So they're just reducing their cycling. They're just limiting the amount of cycling. But yeah, one thing to bear in mind for modulation ratios is that whilst it may be 4:1 at a given outside temp, you are most likely to need the lower output at a higher outside temp when the minimum output is higher. So the effective modulation, max output in winter versus min output in late spring is often closer to 2:1. Potentially, yeah. So I actually understand that the opposite way round. Yeah. So you're talking about the minimum output is higher, but the minimum input doesn't become higher. The minimum input is still the minimum input, and so the modulation doesn't change down to 2:1, because if the building needs 1 kilowatt of heat, my heat pump just won't be able to input 1 kilowatt of heat. So there's the crossover here of cycling and modulation, and sorry if I can't articulate it properly or if I'm muddying the waters, but my heat pump will always, the minimum input is about 500 watts, the minimum heat output is about 2 kilowatts. There's a 4:1 modulation ratio. My heat pump just won't output 1 kilowatt. And so if you start talking in kilowatt hours, as we can measure some in electrical consumption data we talk about, then yeah, maybe, but that then brings in the factor of cycling, and if you're running the heat pump for half an hour, and anyway, it's too much to get into. But no, the heat pumps don't modulate down to 2:1. Thanks. I'd also be looking at the first 3 models, and only the Vaillant seems to quote real figures across different temperatures. So 7 kilowatt would be the nominal with a bit extra, unlike the others where the figures are just fingers in the air. Yeah, and if you delve deep enough, or if you've got approved installers, then they will have further documentation, and they will be able to give you a more accurate table to compare against the Vaillant, but it's just hard to find that data. So hello, isn't the 7 kilowatt Arotherm Plus rated usually at water 35? At air -5, water 35, it generates more like 8.2 kilowatts. Why do you compare with others? Oh, okay. I apologise if my video wasn't clear. This isn't me comparing this at these figures. This is what the manufacturers state. This is on their technical documents. This is their headline figures. And so the ratings, I published the table on the video. The table is there to show at which temperatures the 7 kilowatt unit is actually outputting 7 kilowatts, and the point of the video is to show that that's exactly what the manufacturers are doing. They're comparing 35 against 45 against 55 and -7 against 7 and everything else. That's the whole point. I didn't artificially pick those numbers. Those numbers, if you go and look up the data sheets of all those units, you will see that is how they've rated their units and how they've given it a headline badge and a figure to, label that unit. So sorry if I didn't make that clear in some way. Well done in producing this. It would need government intervention to specify a standard rating and specification across manufacturers. Yeah, it's a shame when we
constantly need intervention and regulation, and why can't industries just sort themselves out? Why can't they just get themselves together as some industry group, heat pump development group body or whatever, and they just talk it out between themselves and just pick a figure and just go with it. It's not really that difficult, and especially for the UK, I know that there is some variation, but if they picked, for example, -3 outdoors with a flow temperature of 45 degrees, that would be my recommendation as a layman, because -3 degrees covers a vast area of the UK. Sorry to you people watching from the very far north of Scotland and much more remote places where your design temperature is lower than -3, but -3 would cover the vast majority. Our heat pumps, our flow temperature should be designed at 45 degrees or lower. So if we went for -3 at 45 degrees, that's where most installers are trying to design the systems anyway. And then those headline ratings would be so easy to understand. I should have put this as a recommendation in the conclusion of the last video, but that's my thinking anyway. Great video. I'm slowly peeling through my onion layers of understanding. I admit I went on trust with my HP Daikin 9 kilowatt install with Octopus, which very happy with so far, so I need to go dig in first details data. My primary view of performance is via my Alpha ESS solar battery app, which shows great real-time energy use in the house, so I can see real-time effects of the heat pumps spooling up and other energy use. Yeah, that's exactly the data I was showing from my solar inverter and a lot of other heat pump owners. If they don't have the monitoring equipment installed, then the solar inverter is one of the great ways. There's other ways you can do it, of course, CT clamps and other things, but that's a good way to do it for a system that is not costing you anything additional to monitor the heat pump. Currently, most heat pump energy use when active is between 300 to 800 watts. Water heating overnight is biggest jump, can spike briefly at first to above 3 kilowatt, then quickly settles to around 2 kilowatt. For most of work, gaps, heat pump not working clearly, larger or milder days, but generally oscillating around 800 watts when working at the moment. This means for me during day, even a poor solar day, my PV covers all house energy plus heat pump, battery fills in gaps and gets charged ready for evening heavy use, cooking and heat pump. Then the cheap rate window I use to top up battery if needed to keep the heat pump house warm, so not working hard first thing next morning. Charge EV if needed, and any hot water heating. Good solar day Saturday. I did all this and fed back 19 kilowatt to the grid. Crazy, not even summer yet. It keeps raining too. Yeah, stay tuned to the channel. I've got some big stats coming on how my solar panel system is working out for us and how impressive my northwest facing roof is. It's far exceeded my forecasting, my expectations, my installers' expectations, and I'm sure it's going to surprise a few of you people how well it has done throughout March. I don't know what tariff you're on, but cheap rate, it sounds like from what you've got there, Octopus Agile is probably your best bet, so hopefully you're on that. But yeah, keep digging, and I think we conversed briefly by messaging that you need to optimize your weather compensation curve, get it dialed in as much as you can, but it's going to be a bit hard for you to get that perfect because it's so mild now, so you'll have to revisit that as we go into next window. That's all the comments for this. I chose to just select comments from the same video instead of jumping around all my different videos. So thank you to everyone who commented on that video. It seems to have really resonated with quite a few people, and it seems to have filled a bit of a void as well as just sharing a bit of information and anything that we can do to try and educate people and also dispel any of the misinformation. And there was clearly quite a lot of misinformation, and I use that word carefully and not disinformation, around the energy consumption of heat pumps. There continues to be a lot of misinformation surrounding the energy consumption of heat pumps. And so anything that we can do to share this with others is a good thing. I keep getting emails from YouTube, and they keep giving me suggestions on how to promote your videos and how to encourage your viewers to share your videos and all this stuff. So you can give us a thumbs up, you can like the video if you want, you can put a comment on it, you can share it with someone. There's a button somewhere that's called a super thanks that YouTube keeps telling me. Encourage your viewers to use the super thanks button. I mean, for me, the most important thing is if you're enjoying these videos and this type of content, then just keep watching my channel. I'm sure you're probably subscribed by now. Keep watching the videos. That's probably the best thing for the algorithm as far as I can tell anyway. It's the best thing you can do to support us to continually keep sharing this stuff, and we can just keep pushing against the misinformation that surrounds heat pumps, because as I'm seeing in the comments, a good chunk of you already have heat pumps, or you are on your journey towards a heat pump. And for me, it's exceeded expectations in basically every area. And so I want to keep sharing this message with people. I've got quite a few videos coming for you. Next video will be our wrap up of our heat pump performance for the month of March, and I'm going to do a video about the whole of our first winter now, which will then I'll try and truncate all of the data, November, December, January, February, March, into a whole winter, bring that together. I've got that video coming soon. Then, as I mentioned, quickly off the back of that, I'll have one about my solar data for the month of March. What else have I got coming up? I've got a little home storage battery update that will be coming in a couple of weeks. I've been working on that, but haven't quite finished putting that video together yet. And then if you've got any other suggestions for me, drop them in the comments. Any video suggestions that you can think of, let me know and I'll see what I can do. Thanks for watching. Bye.